Okay, so today we are going to be doing 10-4, solving radical equations. Alright, so we've got number 1, write it down, it's square root of a minus 3 is equal to 4. Okay, just like you're solving any kind of equation, you want to get the variable on one side by itself and the numbers on the other. So the first thing I'm going to do is I'm going to add 3, do the opposite. This is a negative 3, so I'm going to add 3 to both sides of the equal sign. So the 3 has gone here. I still have the square root, or radical a, is equal to 7. Okay, but we have a radical a, we don't have a a. So what you have to do next is we need to get rid of the radical sign. So in order to get rid of the radical sign, so the square root sign, you take the square of it. And what you do on one side, you have to do the other. So we're going to square the square root, which just cancels that square root and it gives you a. We're going to square 7 times 7 is 49. Okay, so now I have a is equal to 49. You do need to check these. So whether you check it in your head or write it down on the piece of paper, you do need to check to make sure the answer works. Let me find my cursor. Okay, so now we have the square root of 49, that's our a, we found that, minus 3 is equal to 4. So I put it back into the original problem up here. Square root of 49 is 7. 7 minus 3, does that equal 4? And it does. So that checks out. That one works. Okay, the next one. So now we have square root of a minus 3. All of this is in the radical symbol. Where this one over here, the negative 3 was on the outside. So that's why I needed to move this first. On number 1, I had to move the negative 3 and make it positive 3 over there to the other side. But since this is all under the radical, I can't separate it because it's still under the radical. So I need to get rid of the radical sign. So if it's a square root, I take the square and I'm going to square both sides. So when you do that, it eliminates that. So I just have a minus 3 is equal to 4 times 4, 16. Okay, now you're just solving a simple equation. You're going to add 3 to both sides, because I'm doing the opposite. I have my a is equal to 19. Okay, you're going to take that 19 and put it back into the original problem. So now we have radical 19 minus 3 is equal to 4. So the original black problem. So 19 minus 3 is 16. What's the square root of 16? Is the square root of 16 4? And it is. 4 is equal to 4, so we check that one out. Okay, now we're going to go down and do problem 3 and 4. Okay, just like number 1, we have radical x, or the square root of x, plus 7 minus 12, so I'm going to subtract 7 from both sides. So I've got the square root of x is equal to 5, because 12 minus 7 is 5. I want to get rid of the x squared, so I'm going to square both sides. So now I have just x is equal to 25. Take that solution, plug it back into the original problem, and see if it works. So I have the square root of 25 plus 7. Does that equal 12? Square root of 25 is 5. 5 plus 7 is 12. 5 plus 7 is 12, and this is equal to 12, so it does check out. Alright, the next one, a little bit different. We haven't seen one like this yet. We have a square root, so we have the square root of 3n minus 2 on this side. That's all under the radical. And we have n plus 6 on this side, all under the radical. So now I have two radicals equal to each other. I want to solve for n. So I need to get rid of the radicals by taking the square of both sides. When you do that, you just end up with what's inside of the square root symbol. So I have 3n minus 2 is equal to n plus 6. So now we are just going to go ahead and solve a simple equation. So I want to get n's on one side, numbers on the other. So I'm going to go ahead and subtract n from this side and bring it to the other side of the equal sign. It's gone over here. I still have the 6. 3 minus 1 is 2n minus 2. Okay, I need to get n by itself. It's now connected to a negative 2. So I'm going to add 2 to both sides. So now I have 2n is equal to 8. I'm going to divide by 2. And we have n is equal to 4. Take that 4, plug it into the original equation, and see if it works. Not with those. So now we've got the square root of 3 times 4, because now instead of n it's 4, minus 2, it's all under the square root, is equal to 4 plus 6. Okay, 3 times 4 is 12. 12 minus 2 is radical 10. That's what I have on the left side. On the right side, 4 plus 6 is radical 10. These both check out. They're both even, so we're good with that one. Okay, now we've got one more to do. Okay, so here's number 5. We have x is equal to square root of x plus 6. Okay, so we want to get x by itself, but there's an x on both sides. One's under a square root symbol, so I need to get rid of that square root by squaring it. If I square this side, I have to also square this side. So now I've got x squared is equal to x plus 6. Okay, I need to get all the x's on one side. I've got an x squared and an x. It looks like I might be able to make a trinomial. So I'm going to move all the numbers and letters onto the left side of the equation. So I'm going to subtract x here. So over here I have my x squared. I'm going to subtract x and bring it to the other side. I'm also going to subtract 6 and bring this to the other side and set that equal to 0. Now I have a trinomial. How do we know how to solve trinomials? We're going to use our x. Do we need the box? No, we don't, because it has a coefficient of 1 right here. So 1 times negative 6 is negative 6. Add up together to give me negative 1. Remember, the middle term is what we add together to get. So I know 1's going to be negative. So 1's going to be negative, 1's going to be positive. So two numbers that multiply together give me negative 6, but add together to give me negative 1 is going to be negative 3 and 2. So now I've got my factored form. So x minus 3 and x plus 2. But I don't want to factor, I want to solve. I want to solve for x. So to solve for x, you're going to set both of these to 0. And then I take and I solve for x. Let me find my cursor again, sorry. Okay, I'm going to add 3 to this side because I'm going to do the opposite. So now I have my x is equal to 3, and I subtract 2 from this side. X is equal to negative 2. Okay, the very last step, and you must do this, is you need to check your work. So first one I'm going to do, take the original black problem, I'm going to plug in a 3. So 3 is equal to 3 plus 6, because now I'm plugging in that x is equal to 3. That's what I did here, and I made that, and I substituted it there. So I've got 3 is equal to 3 plus 6 is 9. What's the square root of 9? The square root of 9 is 3, so that checks out. Okay, let's do the other one. And let me try the color, change the color again. Let's do it in blue. Okay, we're going to do negative 2. So now we have x is equal to negative 2. I'm going to plug in my negative 2 for x is equal to, take the square root, and I have negative 2 plus 6. I keep the negative 2 on this side. I'm going to combine the negative 2 and the positive 6 to make it a positive 4. What's the square root of 4? 2. Is 2 equal to negative 2? And of course, you know they're not equal. Okay, so this is what they call an extraneous I spelled that right, an extraneous answer. Because we had two answers, one of them didn't work. The only one that did work is x is equal to 3. So even though we came up with two solutions for x, this one did not work. So that's extraneous. So our only answer is x is equal to 3. If neither one of them worked, then it would be a no solution. All right, so that was 10-4.